Okay, hello everyone, welcome. Can you hear me? Okay, thank you. Just we're waiting 1 minute, then we'll start the session. Okay, so we will start this session. So basically today is our fifth number days, and I hope already all of you get the previous recorded video class and also get all of materials for the previous classes. Okay. So basically today's session we discuss about the air quality monitoring using remote sensing technique. I will try to explain all of those beginners to advanced level. Then I hope you can easily learn about that air quality monitoring using remote sensing technique. Okay. So let's go. Let me share my screen. Okay. Okay. Can you see my screen? Is it visible? Okay. Thank you. So let's go. We'll start our presentation. So okay. Okay. So basically, presentation is discuss about that air quality monitoring all parameters such as nitrogen dioxide, sulfur dioxide, or formaldehyde, or methane, or aerosol, okay, or particulate matter 2.5. So this type of gases, how we can easily trace using remote sensing technique. We also discuss about that, and we also discuss about that how to download air quality parameters time series data in CSV file. We also discuss about that, and how to make the air quality monitoring time series chart, and from the time series chart how we can easily check the trend analysis of air quality parameters. We will also discuss about that, and air quality monitoring, how to calculate the total emission of any specific gases. We also discuss about that, and how to calculate aerosol optical depth or AOD. We also discuss about that, and particulate matter 2.5, how we can easily monitor. We also discuss. And today's session I discuss about that also ArcGIS, mainly ArcMap, how to use to make the research paper map after downloading the GeoTIFF file format from Google Earth Engine. We also discuss about that, and accuracy assessment of air quality monitoring map. We also discuss about that, and how to extract the points pixel value for a specific geolocation. We also discuss about that, and how to check the trend of analysis in Google Earth Engine. We also discuss about that, and how to apply linear regression model in Google Earth Engine. We also discuss about that. Okay. So let's go one by one. I'll try to explain all of topic. Then I hope you can easily get the idea how it will be work. So first of all, here you can see this is the two map. So first map, it display about that methane concentration map of width for a specific time period, and another map is the nitrogen dioxide concentration year of 2020 month of January. So this type of map, how we can easily create? So first of all, we need to download the GeoTIFF file format, and further we can easily add the legend, title, or not arrow or a scale. Okay, so this type of things we can easily add using ArcMap. So I also try to show you this type of process, how we can easily work with that also. As well as you can see this is another map. So nitrogen dioxide level rebound in Bangladesh for the different time period. Okay, and then we just make the classification. Suppose very low, medium, high, very high place, we simply identify using nitrogen dioxide level rebound in Bangladesh. So it was the same. We are just downloading the data for different period from Google Earth Engine, and further we are just use here the ArcMap software to create this type of map. And air quality monitoring using Sentinel 5P tropospheric instrument sensor. We are just use it for identify different types of gases such as ozone or nitrogen dioxide, sulfur dioxide, formaldehyde, methane, aerosol. So this type of gases we can easily access from this dataset Sentinel 5P, and this is the link about that. You can simply visit the link, then you can easily access all of dataset. So let's go. I try to show you the practical example, or if you want, you can simply visit the code editor and then click on the browse data catalog. Then we can also get this type of data set. Just click on the Sentinel. And then we work with for Sentinel 5P, Propomi. And here we can find out all of data, aerosol index, then cloud. Also you can see about the formaldehyde, carbon monoxide, then ozone or nitrogen dioxide, okay, then sulfur dioxide, methane. So all of gases we can easily access from this data catalog page. So first of all, I try to show you the one data set, how we can easily work with that. Suppose I want to work for nitrogen dioxide, and if you check, this type of data have two type. One type is the near real time data, another is the offline data. So near real time is more update data, and offline is not more update. So if you click on the near real time, then we find out the more update data. So we find out this data is available. This is the last time period. Okay, so we find out that 3rd July. Okay, this is the last time period. And if you check the offline, so then we find out the data. You can see the 1st July. Okay, so it's not more update. Sometime different types of work we need to work with the near real time. Suppose you want to identify for current data, okay, or current information data, more update data you need, then you try to use the near real time. Okay, or sometime we also use the offline. Basically this data set is more accurate than near real time. Okay, near real time is also pre-process and then add with the offline data. So that's why when you work with update situation or current situation, then try to use the near real time data. So you can see you find out then all of data, sulfur dioxide, it's a near real time. Also you can see it's a near real time, nitrogen dioxide near real time. Okay, and okay, so all of data is the near real time data is available. So when you work with more update situation or current situation, suppose Los Angeles fire, so you want to identify for nitrogen dioxide, so then we try to identify, use the near real time data to get the more update information. Okay, so you can see the formaldehyde, carbon dioxide, all of data is near real time. Only for methane is not available for the near real time. Okay, so it's only for the offline. Near real time we not access for the methane, but all of other gases is available for the near real time and also offline. Suppose I want to work for one data set for the nitrogen dioxide. So near real time and offline both are the same process when you working. So I want to show suppose offline. Just click on here. So this is my data set. We find out, you can see it's the offline data set. Okay, near it's the offline data set. So this data set we can find out between this time period, and I want to work with the data and identify for nitrogen dioxide density map. Okay, where is the high density or where is the high concentration of nitrogen dioxide I want to identify. So this is the data I want to use. So first of all, just simply copy the snippet ID and paste on your code editor. Okay, same process, just simply paste. So now just simply give a variable name. You can put any name as a variable. So in this case, I put the name, suppose dataset. Dataset. So now my dataset is imported in my code editor, and I put the name, variable name is the dataset. So this dataset, after importing, if you check, this dataset have some band, different band. So if you check, this is the one band, it's a nitrogen column number density. So when you check the vertical column of nitrogen dioxide, or you want to check for concentration of nitrogen dioxide, then we try to use it. And we also find out the some different phase, suppose tropospheric phase, stratospheric phase. So different phase we also find out, you can see stratospheric or tropospheric number density or stratospheric number of density. Okay, then we try to use this type of things. So in this case, I want to check for the total vertical column of nitrogen dioxide, mainly concentration of nitrogen dioxide. So I want to use this band. Just I copy this band, and this unit is the mole per meter square. Okay, further we also check, change the unit, or micromole, or ton per meter square, or micromole per meter square. Okay, so we'll also discuss about after some time. So further, just simply use here the select function and then paste here this band. Okay, so then simply filter your time period, basically when you work with that. So just put the filter date function and put the specific time period. So in this case, I want to work for, suppose, year of 2024, 1st January, from year of 2024 December 31. I take the 1 year data, and this 1 year data I just simply filter bounds with my study area, which is okay, RY. Then I simply import my study area shapefile. So in this case, suppose I want to work for this area of interest. So Dhaka said I simply import, and I put the variable name is a ROI. Okay. So now let me check how many images are available for my study area between this time period for 1 year. Just print and call the data set and use here the size functions, computing how many images are available. So we find out this is the total number of images, 5150 images are available between this time period. So this is my data set. So I want to use the data, and further I want to make the, suppose I want to make the time series chart and then check what happened. So this is my image collection, and we already know about that how to make the time series chart. So further we simply call the function UI chart image.series. Okay, we already used the function. Simply search here UI dot chart dot image. So we can easily find out this function. Okay, just simply import the function in here. So after that, we already have image collection. This is my image collection. Just take copy and paste here. And region of interest, this is my ROI. I already imported my study area and put the variable name as the ROI. Then reducer, we can put any name as a reducer. So I put the name, suppose okay, just I put the name ROI. I put the ROI, and then I want to reuse. Suppose I want to calculate, suppose, average concentration. So just put here reducer.min. Scale is the resolution of your data set. So in this case, my data set resolution, if you check, it's at 1113.2 meter. So this is the pixel size of my data set. Just I use and paste here. And X property, we are just using at the default system time start. System time start. So this is my chart code. Now these things just simply store it in a variable. We can put any name as a variable. Suppose I put the name is that chart. Okay. So then just print the chart. And run the code. So now it's generating a chart. Okay, so we face this type of problem. So here you can see error generating chart, collection query aborted after accumulating over 5,000 element. So in this time we find out the 5,150. So it's across the limit. So this type of problem we face lot of time when you work different types of data set, not only for that, any data set. When you face this type of problem, it means that chart is not work now. Okay, so now chart is not work because it across the limit. So if the image collection below the 5,000 element or below the 5,000 image, then chart is easily worked. But in this case, my image is across the limit, so it shows the 5,150. So that's why the chart is not work, but I need the data. So how I can do that? So for this solution, we are just download the data directly using CSV file. Okay, just we make the CSV file and just we are use the CSV file and download the data. Okay, so how we can easily download the CSV file, I will show you that after some time. But in this time I simply reduce my time period. Suppose I want to need the data only for the month of January. Okay, so now let's check what happened just on the code. So now you can see it reduce our image collection. We find out the only for the 417 image. So now easily chart is appeared. But previous time when I put the 1 year, so it across the limit 5,000 element. So that's why chart is not appeared. Okay, but we can also download the data, no problem. Without creating the chart, we download the data as a CSV file. Okay, so I will show you this process also after session. So here we find out the total 417 images, and if you check, we find out this type of time series chart. So here you can see this time series chart have a problem. What's the problem? This problem is that it show the 0. If you check, it show the density is the 0, 0, 0, but it has a value. But now this value show as a round figure 0. Okay, so how I can display the value? So now in this time we need to convert the unit. So now this chart, this unit is mole per meter square. Okay, this unit is mole per meter square. So when I calculate the chart mole per meter square, so this value is very less. Okay, so Google Earth Engine chart, it automatically show the round figure as a 0. Okay, you can see automatically show the round figure as a 0. But when you convert the unit in micromole, then we find out the value. This type of chart, we find out the value. Okay, when you convert the micromole per meter square, so now it show the result mole per meter square. So that's the region it show the round figure as a 0, because when I compute the result in mole per meter square, this value is very less. Okay, inverse 10 or inverse 5. So that's why chart automatically show the result as a 0. But when you convert the unit micromole per meter square, then we find out the value. This type of place we find out the value. So let's go try to convert the unit into micromole and then check what happened. So now how I can convert the unit? So if you simply search mole to micromole, so we find out 1 mole equal to this micromole, and multiply the amount of substance value, 1 is 6. So when you multiply this value, with your mole result, then it will be convert as a micromole unit. Okay, so let's go simply multiply this value with our all of images. Okay, I have total 417 images, and I need to multiply this value all of images to convert the unit mole to micromole. Okay, so let's go try to multiply and then check what happened. So for the multiply, in this time we create a function. This function help you to multiply all of images at the same time with this value. Okay, so let's go try to create a function. Okay, and this function help you to multiply all of images at the same time. So let's go. So for that, take a variable. I put the variable name, suppose I put suppose micromole dataset. Okay, and I create the function keyword and put the element name img. So now what is my argument? My argument is that I want to use this element and multiply this value. Okay, this value I want to multiply because I need to convert the unit. So for that, I want just use at the return this element multiply this value. Okay, so now it work only for the one element, but I have also rest of others element because they're the total 417 images. Okay, so now just I copy these properties after multiply, just I copy these properties, this element, and apply my system time start to system time int, system time start to system time int. Okay, so this is my argument. So first of all, I create a function. This function I simply return this element multiply this value because I want to convert the unit mole to micromole, and this multiply I simply apply all of images which are available between this time start and this time int. Okay, so now this is the function. In this function I need to just input my collection. Okay, so this is my total collection, 417 images. This is my collection. It is stored in this variable. So just I copy and paste here. And for connecting, we already know about that. Use here the map function for connecting. Just put the map function. So now it create the data set, but this variable now stored the data set in micromole unit. So I want to use it and create the chart and then check what happened. Just run the code. So now if you check the value, we find out, you can see, we find out the number. Also all of vertex, if we can find out the number. In the January 3rd, we find out the average density of nitrogen dioxide in Dhaka city, 130.99 micromole per meter square. So if you check another, this time, or check this time, okay, so we find out that you can see all of vertex. Now it display the value. Okay, and it show the daily data. We find out the daily data, 7 daily average data. Okay, for concentration of nitrogen dioxide in Dhaka city region, month of January 2024. Okay, so now it show the display the data. We find out the high concentration January 21 2024, 605.941 micromole per meter square. We find out, and you can download the data as a CSV file. Just click, then you can find out the data as a CSV file, and also download the PNG file format. Okay, so this is my time series chart I find out. So now I want to check what is the trend. I want to use the time series chart and then identify for trend. What is the trend for nitrogen dioxide in Dhaka city based on month of January 2024? It will be high trend or low trend. So this type of analysis I will do using the chart or using the time series analysis. So for that, if you want, just check the trend for the nitrogen dioxide concentration in Dhaka city based on the month of January 2024. So for the reason, you just add some code to adding the trend line. So for that, just use here the dot set options and simply add some chart option such as chart title, X label, Y label title. So I put the title. Suppose I put the title. Suppose NO2 time series chart. You can put any title, and then put the suppose Y label. Y label I put here suppose V axis title. It display about that suppose micromole per meter square unit. Then Y level, X level, basically horizontal axis, X axis, horizontal axis, it display the title, suppose time. Okay, and if you run the code, So now it show this type of problem. If you check, we find out this type of problem. So this chart is not continuous line. Okay, it's not show the continuous line. So for creating the continuous line, we are just open one new argument. So when you face any problem for any data set, this type of problem, it's a line breaking chart or not continuous chart, line chart, then you try to use this argument. It called the interpolate nulls. Okay, interpolate nulls. Simply open, just use at the true function, true for open. So now if we run the code, so now it display the continuous chart. We find out the continuous chart, as well as it also added the chart title, y level title, x level title. You can easily find out in here. So now I want to create the trend line. What is the trend for the time series chart? I want to check it. For the trend line, just use a one argument. It's called the trend lines. Okay, just put the trend lines. Okay, so in the trend lines, basically it show only for the one line. Okay, one line or first line. And JavaScript programming 0 is referred to the first item. Okay, 0 refers to the first item. So now it's only for the 1. So 1 0 is refers to the first item. So I put the 0 and then put the some argument. So first of all, type. Okay, so we know about that different types of linear trend line: linear, polynomial, exponential. So I want to apply suppose linear. So just put here the linear. And now if I run the code, so now it added a trend line. So we find out this type of trend line. Okay, this type of trend line we find out in here. Okay, so we find out that it will be increasing. Okay, this trend line show the increasing the concentration of nitrogen dioxide day by day based on the month of January 2024 data. We find out that this is the uptrend or positive trend we find out in here. Okay, so now we also add some different option. We just style different types of style using the trend line. Suppose I want to apply the color and I put the color is the red and run the code. So now this trend line display the line as a red color trend line. We find out, you can see it show the red color, or you can put any color in here. And then suppose you want to add for increase the line width. So for that, just put here the line width. So I put here 6 and run the code. So now this line width is also increased. Okay, we find out. And then suppose I just simply decrease the opacity of the line color. So for that, just use at the opacity and put suppose 0.2. Just run the code. So now it also decrease the opacity. We find out this type of opacity. Okay, and if you want, you can also add here the legend. So in this time, if you check, it just show only for the one legend, this line legend, but I want to display this trend line legend. I also display in here. So for that, just open another argument. It's called the trend line. It's called the visible in legend. Okay, and then open it. Just use here the true and run the code. So now it also display the legend. You can see we find out the legend for the trend line legend. So we can find out this type of this is the legend for trend line, and this is the legend for time series chart. Okay, we find out this type of things. So now this is the way how we can easily create the trend line analysis any data set, not only for the air quality parameters data. So if you want to check any data set trend line analysis, just apply this way, then we can easily find out this trend line. Okay, anyone any question, you can ask me please. Any question? Okay, I hope there is no question. Okay, so let's continue. Okay, so we check about the trend line. What is the trend of nitrogen dioxide? We find out that is the uptrend line. So it means that day by day increase the temperature of nitrogen density is the increasing for our study area. We try to check it. So now I want to display the map for the spatial distribution for nitrogen dioxide. Where is the high, where is the low? I want to check it. For that, I need to add the map. So for adding the map, okay, let me add the map. Then we can easily find out the spatial distribution. What is the high concentration, what is the low concentration, we can easily find out. So map. So for that, take a variable. Suppose I put the variable name is that mean NO2. Suppose I calculate the average concentration of nitrogen dioxide using this data set. Okay, I already create the data set micromole, so I want to use it for micromole data set and then create this map. Just paste here, then apply here the mean function. So now it's compute the average pixel of nitrogen dioxide density and clip with my study area, which is RY. So now we try to display our study area for adding the map.add layer, and call the mean NO2 and run the code. Okay, but it not focus my study area because we need to add the map.center object function for focus on the center given study area RY. So now run the code. So now it directly focus on my given study area. We find out. Okay, and also added the map. So we find out this type of white color map. Okay, without visualization. So let's go try to add the visualization and then check what happened. So for that, they are already provide some demo color code. If you check, so this color code I want to use. Just I copy and paste here. So in the color code, basically they are make a dictionary. Okay, you can see they are make a dictionary. In the dictionary, they are mentioned about the mean and max range in mole unit, but I want to calculate it micromole. So I need to change the mean and max range. So we can easily change it. Click on here and stress the data. Suppose I keep 98% stressing. So now it automatically show me the mean and max range. Just I copy and I put here it's a mean and then copy it's a max. Just I copy and paste here. Okay, then this variable copy and paste after the object name, because after the object we always put here the visualization parameter, then put the layer name. I put the layer name, suppose NO2 map. So now run the code. So now this map, it show the display the visualization. We find out this type of map. So from this map we find out this type of place. If you check the color bar, so this type of red color, it's indicating about the high concentration place of nitrogen dioxide. This type of red color we find out. Okay, and if you check this type of black color, it's indicating about the low temperature, low concentration of nitrogen dioxide. Okay, so then it gradually increased. It gradually increased. We find out. So this is the concentration map we find out, and it look like this type of way, because this data set 1 pixel, this resolution is that 1113.2 meter. So that's why we find out this type of cell or this type of grid we find out. Okay, but when we apply this data on the big study area, then this type of cell or this type of grid, it is not visualized. Suppose this data I want to apply for whole country boundary of Bangladesh, then check what happened. Just simply import my study area. So just I simply import and I simply change it. Just I remove the previous one. Just I delete and I put the name as a ROI. So now this is my study area and I just run the code. So now this is the result for whole country boundary of Bangladesh in year of 2024 month of January. But we face a problem. It show okay, layer error, description length exceeds the maximum. Okay, let me run again. Okay, I fixed the problem. Yeah. Okay, I think this problem occurred for this function map.center object. Okay, just I comment and then run again, then check what happened. Okay, show the problem. Okay. Yes, please.
Yeah, thank you. Sorry, but can you go back a little bit and explain better how to convert to micromoles? The function, the function of line 8, I guess.
Yeah, this one.
Yeah,
Yeah. Yeah.
yeah.
Okay,
Thank you.
so in this time we just convert the unit in mole to micromole. Okay, mole to micromole. And mole to micromole when you convert, then we need to multiply this value with the mole result. Okay, so that's the region. We just create a function and multiply all of images between this time period, all of images, basically 417 images we have. So now we create a function. Okay, this function help you to multiply all of images with this value. Okay, because I need to multiply this value with my mole per meter square unit dataset. Okay, so such simply multiply, but it has only for the one element. Okay, only for the one element we take, but I have also rest of the other images. So for that we simply apply the copy properties and apply it from system time start to system time end. Okay, which is indicating this time period. Okay, and now this is the function I created. This function we need to connect with our data set. Okay, so simply call the data set and then use here the map function for connecting this function which I created. Okay, so now this variable is stored at the data set and this unit is micromole per meter square. Okay, so further we are just use it and display the chart. Okay, and now we try to display the map for micromole unit. Okay, but it show a problem. Okay, just a minute.
Thank you.
Okay. Description length exceeds the maximum. Okay, just a minute. So let me try another boundary. Suppose I just call the data from USDS website. This is another data source. This provide the international country boundary polygon. So from here I just choose my study area. So for that take a variable, suppose RY, and call the table. Then filter earth engine dot filter dot equal. So just put here the country name and put the name, suppose Bangladesh. Okay, so now this variable is stored at the Bangladesh country boundary. So now run the code and then check what happened. Okay, so now it's work. Okay, so now we find out this type of map. So I want to create the more better map. So simply change the mean and max range. Just click on here and I keep the stress 98% and copy, paste here, and also copy and paste here and run the code. So now if you check, we find out this type of map of concentration of nitrogen dioxide, and it's look more better because now this data set we apply for the big study area. So now we can easily identify this place is the high concentration of nitrogen dioxide. Okay, due it's a capital of Bangladesh in Dhaka city. So then we find out it's a high resolution, high density of nitrogen dioxide due to the different types of anthropogenic activity in here, or there are a lot of vehicle. Okay, that's the reason we find out the very high. And if you check this type of place, it's a hilly region or hilly study area. So that's the reason we not find the very low concentration of nitrogen dioxide. This type of place we find out it's a black color, and this is the mangrove forest, it not mass. Okay, we can also check this is the another. So this is the city port. Okay, port, so that's why it also shows some high density. Okay, we also find out in here. So this is the result only for the month of January. Okay, only for the month of January 2024. Okay, so we find out this type of map, this type of concentration map. So if you check the value, suppose click on the inspector tab and click this type of place, so it display the for this coordinate we find out that 348 something micromole per meter square concentration of nitrogen dioxide. So if you check this type of place, so it not mass, we find out that 49 point something, okay, micromole. So this is the concentration map of nitrogen dioxide, you can easily find out in here. Okay, and this is the time series chart. This is the time series chart, we can find out in here. Okay, so now I discuss about that how we can easily extract the CSV file. Okay, because sometime chart is not work. So if you check, if I just increase the time period, suppose I put the 1 year, then the chart is not work. We face a problem because it across the limit. Okay, 5000 over the across the limit 5000 element. So that's why we find out the error, chart is not work. But I need the data for 1 year. So then we are just download the data as a CSV file. Okay, CSV file data. So let's go ahead and discuss about that how we can easily download the CSV file. Not only for this data, any data set, you apply the same process for any data set. Just apply the same process for creating the download the data, okay, in CSV file format. So let's go how we can easily create the CSV file. So in the CSV file, if you check, we just need to create the 2 column. Okay, we need to create the 2 column. Suppose first column show the date, another column show for the value. Okay, so this column show for date or time, and this column show for the value or stat, we find out in here. So how we can easily create this type of things, so let's try to explain. So first of all, we just generate a function. Okay, suppose I create a function, so I put the variable name, suppose CSV, and put the function keyword and put the element img. Okay, so in this case I just use this element and I have 2 argument. First argument, I want to extract the data for each images, and then each images I create for average or maximum or minimum concentration. Okay, so let's go try to put, suppose first of all take a variable, I put the variable name, suppose date, and from this element I just extract the date. Okay, and then I just apply the format function, format function. Format, it can be year, then month, and day. Okay, this type of format, or its default format, there is no problem. Or you can put only for the year, and put here suppose month, skip the date, or also add the date. Okay, there is no problem. Or if you just put the blank, then it also automatically added the date and year, no problem. So just apply the date and format function, and then take the another variable, suppose stat. In this variable we are just calculating the value for each images. So just I call the img. So you can see if we face this type of problem. Okay, when you apply the data for the big data, okay, over the element 5000 element, then we find out this type of problem. Not only for this data, any data set when you work, we face this type of problem. So for this solution, we need to download the data CSV file. Okay, so for that we create the date and also create the another variable. So this variable mainly we just extract the average value for each images average value. So put here the reduce region function to compute the average value, and now we put here first argument reducer. Okay, put here ee dot reducer dot mean, then put here the geometry, it's your shapefile which is ry, then scale is the resolution 1113.2 meter. Okay, and after that we take a variable, suppose big, and call the date and also date, make it keyword and key value same, and also stat and also stat. So this take a variable and then simply make a dictionary. Okay, just same keyword and same key value just put in here. After that, what I return from this function, so for that put here the return function, return okay. So just put here the return. So I want to return feature ee dot feature. CSV is considered as a feature. Okay, and this feature there is no geometry. So for that put here the null, and then set with this variable. Just copy the tick and paste here. Okay. Basically e dot features, it is one kind of vector data type, but in this time there is no geometric information, so that's why I put the null and then set with this dictionary. Okay, so this is the function. Okay, this is the function, and this function you just connect with your image collection. Okay, so I already have the image collection, I already make the image collection micromole dataset. Okay, or same only for this dataset, basically mole per meter square dataset. So I want to download the data in micromole dataset, just copy and paste here. Okay, then just use the map function for connecting. Okay, so now this is my variable CSV, and if you check the value, suppose print the CSV. Okay, I take the check the first value from this CSV file. So we find out that feature. Okay, first features, so it show the geometry null, and if you check the property, so it show the this is the date. Okay, and also show about the time, and you can see the value, so it show the value. Okay, so let's go try to make the download the CSV file using all of those data.